Good morning, everyone. Well, good morning, everyone. Well, last time we had this introduction about quadratic functions as a general form, and we discussed that A, B, C are parameters. When we assign values of for ABC, and we will get specific quadratic functions. Okay, and the function we have learned. Okay, so let's take this quadratic function with parameter, right? With parameter ABC. And we have seen these examples, right? We have seen these examples from last time. And we're going to see some more examples this time. Okay, for example, if we set A equals to 1, B equals to 0, C equals 0, and we will get a quadratic function. We'll get a quadratic function. And what is this quadratic function? A is 1, B is 0, C is 0, right? 0 times anything is 0. So in the end, 1 times x squared is just x squared. And we ended up with the quadratic function we just worked with last week, right? It's x squared. So x squared is a special case of a quadratic function. Okay, so let's look at another example, right? This time I'm going to still keeping A equals to I'm going to keep A equals to -1, and B is 0, C is 0. So this time is a negative x squared. So this is 0, 0. So I'm going to get a negative x squared. And doesn't this look familiar? Negative x squared. Didn't we graph x squared, negative x squared before? We did, right? Good morning, Alan. Good morning, Marcelo. Okay, so we continue the topics we had last time. We talk about the, this quadratic formula may look kind of complicated, but it's really a represented a general form. It's a general form of all of these other quadratic we have studied, right? So here we go. We got an x squared. Right? If we assign ABC with a specific value, we get x squared. And we saw negative x squared, and we know the graph, right? We know the graph. And what else do we know? Okay, so I'm going to bring up the pictures that we did before. Okay, these pictures. There. Okay. So when A is 0, A is 1, B is 0, C is 0, we got x squared. We know x squared. When A is -1, B is 0, C is 0, we get negative x squared. We know negative x squared. And if we keep going on this list, okay, if we keep going on this list, suppose I have, oh, sorry, not again. Okay, so suppose I'm going to have A equals to 1, A equals to 2, B equals 0, C still equals 0. So A is 1, it is 2. And that turned out to be 2 times x squared. Do we know 2 times x squared? Yes, we do, right? We did it. And what if we turned A equals to 1/2, right? If we do A equals to 1/2, and then we're gonna have half x squared. Do we know the picture of 1/2 x squared? Yes, we do. We did it, right? That's the blue in here. And 2x squared is a green, and negative x squared is a red, and x squared, of course, is a black. Are you guys with me? Now, more examples, right? Suppose I have, okay, here, this should be half, sorry, got to change that. Okay, so if I keep going, I'm going to give you another set of values. This time, A equals to 1, B equals to 0, and C equals to 1. And let's see what we have, right? We still have this function here, the general form, and we plug in the A equals to 1, B equals to 0, and C equals to 1. What do we end up with? We end up with x squared plus 1. Do we see this graph? Did we do this graph? We did, right? Now, we still have A equals to 1, B equals to 0. I'm going to have C equals to -1. So this time it's -1. So now I get x squared minus 1. Did we see x squared minus 1? Yes, we did. Does everybody follow me? We are discussing this general form of quadratic function. Okay, when we assign different values of A, B, C, we can get all of those other functions we have graphed last week. Okay, now some more. And this time, I'm going to assign A equals to 1, B equals to 2, C equals to 1. Okay? And I'm still going to work on this function to see what do I get as a consequence. A equals to 1, B equals to 2, C equals to 1. And of course, A is not 0, so I don't need to worry about it. And what is this? X squared plus 2x plus 1. And I'm telling you, does this form look familiar with one of the perfect squared we worked with? Everybody, so please look at those perfect square tables we have worked on. What do you see? What do you see? Is this a perfect square? If it is, what is it? Let's see what's on chat. Good morning, Marcelo. What is that perfect square? Could you guys give me that perfect square? What is that perfect square? Did you find it? In that perfect square table. In that perfect square table. What have we found? What is it? What is it? Come on, guys. It's a foxtrot. Marcelo, what is that perfect square? Alan, what is that perfect square? X squared plus 2x plus 1 Francesco. Okay, good morning, Francesco. We are working with this quadratic form for A, B, C being assigned different values, and we get all these different special cases of quadratic forms. And we are familiar with that form. When A is 0, A is 1, B is 0, C is 0. Okay, so you can see this is a general form indeed. This is a general form indeed. It can include all of these and more. So what is a perfect square for x squared plus 2x plus 1? Everybody, could you guys find that perfect square table and tell me what is that perfect square? Ellen? What should be in the parentheses? What should be in the parentheses?
X minus 1.
X minus 1. Thank you. Does it work? Can you verify? Can you verify? How do you verify? You multiply x minus 1 with itself, right? We multiply x minus 1 with itself. So what did you end up with? What do we end up with?
X squared minus 2x plus 1.
So x squared minus 2x plus 1.
Yeah.
So what do we have here? We have x squared plus 2x plus 1. So is x minus 1 squared the perfect, this perfect square is the same as this one?
No.
No. So something need to be changed, right? So what is it? So you either change the equal sign or you change this form. Yes? So x squared plus 2x plus 1. What is that? What's that perfect square? That is the same as x squared plus 2x plus 1. Did you guys find it?
X plus 1 square.
Right. X plus 1 squared will be that perfect square. Okay, did you get it? Are you guys with me? We bring the lectures the last few times together. Okay, we did the perfect square, right? Remember we did the perfect square exercises. You had the quiz. How did you do on the quiz? How did you do on the quiz? Do you have any questions on the quiz? Yeah. Right. So you recognize this is a perfect square. Then you probably start thinking, well, are there cases that you end up not being a perfect square? Of course. We will lead you to that. We'll lead you to that. Okay. We also recognize that if we have some perfect squares, it would be so much easier to graph. And do we know this curve? Did we graph that curve? We did, right? And which one is it? It's the green, right? It's the green. Yes? Does everybody follow me? Now, another example. And this time, I'm going to give you A equals to 1, B equals to -2, C equals to 1. And what will be the resulting quadratic function? What will be the resulting quadratic function when we plug in? A is 1, B is -2, C is 1. The 1 in front of x squared can be omitted, right? So it's just x squared minus 2x plus 1. Does this make a perfect square? Does this make a perfect square? Does this make a perfect square? Can you guys look at the perfect square table we did last time?
Yes.
And what is it? What is that perfect square?
X minus 1.
X minus 1 squared, right? Wonderful. So the list can go on, right? On and on and on and on. But one day, as you keep this list go on, right? And we know that, oh, all these functions we have graphed, right? How many did we graph? 1, 2, 3, 4, 5, 6, 7, 8. We have graphed 8 of them. And you were being quizzed in, multiple times. Now, as we have this list going on, and you know that ABC can assume any numbers. ABC can really assume any numbers. So for example, I can totally make A equals to 1.2, B equals to 2/3, 2/3, okay? C equals to -100. Will I get a quadratic? Of course, I will, okay? And that form is going to look like this. Okay, this is 1.2, and this is 2/3, and this is -100. Even though this doesn't look as nice and neat, it is not even a perfect square, but it is still called a quadratic function. Do you guys follow me? It is still called a quadratic function. So how many quadratic functions do you think we can generate with this general form? How many quadratic functions can be created with this form, which is like that? How many? Tell me. How many do you think we can generate at this rate? What is your answer? Infinite, right? Right? Infinite. We can just manipulate the values for ABC, okay, and generate as many quadratic functions as possible. Generate as many quadratic functions as possible. So the answer is infinite. Infinite. And we are only going to use a small portion of the infinite. In particular, we're going to use the small portion of the simple quadratic functions. And that's being used for academic reasons. Okay? Okay, you're going to see while you're taking these classes, you study your major, whatever major in STEM, you are going to see a portion of that quadratic function. And we are, in this math class, we are going to handle a few of them, some easy ones. So what are the easy ones I'm talking about? The easy ones I'm talking about, usually the ABCs are integers, okay? You rarely have to deal with fractions. Sometimes you do have fractions, really, okay? In real life, you will have decimals of fractions, and if you major as a business, you will learn that some of the business mathematical model, you have ABCs, maybe just decimals, fractions of all kinds of numbers. But we're dealing with the simple set of quadratic functions. Does that make sense to you? And we're going to talk about how to handle these. Okay, we have seen the pictures of all of these special cases. We have seen the pictures of all of these special cases. That's what we have seen. What have we seen in these pictures? And of course, we also have we have two other examples, right? We have two other examples back some time ago, f of x, f of x. I forgot exactly what those examples are, but I'm going to just show you that, say 2 times x minus 3 squared plus 1, something like that, right? G of x equals to, g of x equals to 1/2. And let's put a negative sign in front of it, right? X plus 3. I'm just creating some new ones, okay? They don't have to be the same. Minus 5. I'm just creating these functions randomly. There's a perfect square there, okay? Or maybe I just put a 7. Okay, just make them different, right? Just make them different. All of these, they are quadratic function too, because if we expand it, okay, if we just FOIL and organize the term, and then we actually will see that that's a quadratic function, which A is 2, B is negative 12, C is 19. Okay, A is 2, B is negative 12, C is 19. And this one, if I expand it, okay, what do I get? I get A is negative 1/2, B is negative 7, C is negative 59/2. So you can see we have as many quadratic functions as possible, yeah? As many as you wish. You can create one very easily. Okay, but all of these quadratic functions, they have something in common. What is that something in common? A, B, C are given. The variable x, which is the input, is being squared. Power 1, power 0. So that is the feature of a quadratic function. Does everybody follow me? So now let's create another one. Let's create another one. Are you ready? Create a quadratic function. This time, I'm creating a quadratic function. I'm going to create this function as A equals to 1, B equals to, let's see, 2. C equals to negative 3. And what is the consequence of this creation? A is 1, B is 2, C is negative 3. Boom. I have just created a new function. I just have created a new function. Is this new function a perfect square? Can you go through your perfect square table to see if you can find a perfect square for this entire function? Can you find one? Can you find one? I bet you can't, because this one is not a perfect square. In particular, you see x squared plus 2x, that looks promising, but you have a -3. No, it's not a perfect square. Not a perfect square. So how are we supposed to graph it, right? We know how to graph all of these functions, right? We know how to graph all of these functions. We spend time graphing them. And we also know how to graph these two functions. Do we know how to graph these functions? We know all the shifting, reflecting, shifting left and right, shifting up and down. Do we know how to do that? We do, right? We know how to do that. And now what do we do? Now what do we do? Of course, we can plot the points with our shear force. We can certainly plot points. But when you plot points, the domain is all real numbers. So where do you start? Do you start at 0? That's a good place to start. That's certainly a good place to start. We can start from 0. Okay, so this question will take us to alpha 19. Alpha 19. Okay, so we have discussed the graphing of the simple form of quadratic, and we've done some perfect squares, and now we are going to get to alpha 19. Okay, alpha 19 is a big question. Okay, it has in itself 26 questions in itself. Okay, it has 26 questions in itself. So this is going to take some time for us to finish. But what I hope is at the end of finishing this, you understand the quadratic, at least this particular quadratic, much better. Much better. Okay, so now let's look at alpha 19. Alpha 19. Okay, we're going to study alpha 19. Why we study these kind of functions? Because this class of function, okay, quadratic function is a class of function. Okay, it's a class of function. This function is widely used, at least throughout your academic career. Okay, as long as you're in STEM, as long as you are, even if you're in business, okay, as long as you have to take math classes beyond, in intermediate algebra or beyond, you will have to know how to deal with this function. And this function is the perfect academic questions. Okay, it will teach us much and we will learn much from it. And in particular, we're going to learn a lot of interesting mathematical ideas. Interesting mathematical ideas. Okay. One of the things we have seen, okay, we look at this function and we recognize this is something x squared plus something times x minus 3. And first of all, we know this function domain, this function's graph is a parabola. What is a parabola? All of these pictures are parabola. All of these pictures are parabola. We have 8 parabolas here. I mean, 8 different parabolas. Okay, I didn't count the x squared twice. The x squared is only counted once. All of these are parabola. This is a parabola. as well, except we don't know where it should be positioned. Okay? From here, we can tell if A, okay, in this case, in this parabola, A is 1, B is 2, C is 3. C is -3, sorry. C is -3. From the value of A, okay, from the value of A, when A is positive, right? We know A cannot be 0, but if A is positive, the parabola is going to opens up. Opens up. How do we know that? Because we have observed all of these parabolas, right? Do you guys remember what we have done? X squared, for x squared, right? For x squared, it opens up because A equals to 1, positive. For negative x squared, A is -1, it opens down. 2x squared opens up. Half x squared opens up. A are positive. Do you follow me? For all of these other cases, A are all positive. Okay, and many examples. A is negative. In this case, A is positive. By plotting many parabolas, mathematicians before us, right? Maybe 200 years ago, literally 200 years ago, you know, mathematicians studied quadratic. And they found when A is positive, the parabola opens up. So from this experience, we understand this is going to be a parabola, and this parabola is going to open up. Do you follow me? Now, secondly, if it is a parabola, it's going to be symmetrical. It's going to be symmetrical. So if you can find that line of symmetry, you fold it. Okay, imagine folding the curve along that line of symmetry. It's going to overlap. The two pieces will overlap on each side. And the line of symmetry in the third picture here, obviously, is no longer y-axis, but we can always find a line of symmetry. Okay, so from this function, we know a couple of things. Okay, this parabola opens up. Okay, all of these we're doing now is just analysis. Okay, I will show you how to do the work. Okay, if you show work, what you do. Okay, you don't have to show, you don't have to write down so much. Okay, this parabola opens up and it has a line of symmetry. Okay, it has a vertex. What is the vertex? We had a homework about vertex, right? The vertex is basically the lowest point or the highest point. Okay, the lowest point or highest point. For example, on all of these curves, 1, 2, 3, they have the lowest point. On the red curve, which opens down, it has the highest point. And all of these curves in the second picture, they all have the lowest point. And you can imagine if you flip them over, you're going to have the highest point, right? And all three curves here, they all have the lowest point. So when A is positive, we will have a lowest point. When A is negative, we are going to, what happens if A is negative? When A is negative, the parabola opens down. Okay, so in this case, it has a highest point. And in this other case, it has a lowest point. You follow me? Does everybody follow me? Okay. This is like an introduction and just give you some ideas about what we're up to. Okay, which we're going to cover gradually, or over the the 20 plus questions, So, and how, of course, from the graph, you can see a bunch of things, but how do we express it mathematically? That's another thing, right? Many of us have to learn how to express it mathematically, even though we understand the picture. But when we express it mathematically, we kind of express it more concisely. Okay. So now let us follow the order of these questions, and we're going to go over it one by one. Are you guys ready? I promise you this ride is going to be a little bit long, but it's a very comprehensive set of questions. This set of questions will help you understand pretty much everything about quadratic. Pretty much everything about quadratic. That's why you see in the title, in the title of my Canvas, the title is Everything Quadratic. Everything Quadratic. Okay, so if you understand all of these questions, you understand a lot. All right, and I'm sure you will. Okay, so the first question is that, and of course, in this question, in this alpha 19, I actually give you the picture. I have given you the picture. Gradually, we're not going to be having a picture. Okay, we're going to have to work it. Okay, but don't worry, we're going to do a little bit at a time. Now, alpha 19. The first question. If we see this as a function, right? Do we still remember what function is? Input, output, right? Input, output. What will be the domain? What is the domain? In other words, what are the numbers that will be fitting for input? And that answer, what do you think of the answer? What do you think will be the domain of this function? You look at that curve in front of you, right? It can go as high as possible. It goes up indefinitely as long as you wish. To eternity. So what is the domain? What is the horizontal span? Could I solicit some opinions from Brianna? What do you think? What do you think will be the domain? What would be the domain? What will be the domain? The question you'll be asking, right? What number will be qualified as a domain? Which means that you pick a number, you pick that number, you plug in, and it's going to produce exactly one output, right? That's the definitional function. For any input, there's exactly one output. So do we have that? What are those numbers? No answer? The answer is all real numbers. Any real number we can plug in and produce an output following this rule. Okay, you give me a number, I'm going to plug in. Okay, let me give you some examples. Let me give you some examples, right? So if you give me the input x equals to 1, all I have to do just f of 1, right? F of 1. So this is 1 and that is 1. Okay, so what do we get? We get 0. So input is 1, output is 0. And this process can go on and on indefinitely, forever. You can have any number as input. That's what we mean by the domain is from all real numbers. To answer this question, you don't need to show all of these to me. You just have to tell me the answer here. You follow me? Does everybody follow me?
Yes.
Okay, so the domain is all real numbers. I was just explaining to you how to observe this. The second question, you see, the second question, I did not ask you for a range immediately because you cannot answer that, because we cannot answer that question yet. We cannot answer that question yet. The second question is concavity. What is a concavity? Concavity means, is it concave up or concave down? Does it open up or open down? That's the same meaning, okay? So this picture, okay, because it has this cavity, we call it concave up or concave down. Because A is greater than 0, okay, A is 1, it's larger than 0, therefore it's a concave up. You follow me? So from the value of A, we know it's opened up or opened down. And of course, this is also called concave up or concave down. Do you follow me, guys? You're learning all these new words, don't you? You're learning all these new words. Concave up, concave down. The third question, okay, the third question, it's asking for y-intercept. Y-intercept. What does it mean by y-intercept? It's basically asking us, okay, if we graph this curve, we have x-axis, y-axis. Where does this curve cross the y-axis? Okay, where does that curve cross y-axis? Then you'll be asking the question, what are the features of the points on y-axis? What is the feature of the points on y-axis? Okay, so I'm going to bring up the rectangular system. Okay, don't worry about why I put y equals 0 here. I'm just to start this graph. Okay, I'm just starting this graph. So this question is that we know we're going to have a curve. You already see the curve, right? Where does it cross y-axis? Well, every point on y-axis, they have something in common, don't they? If you look at the points on y-axis, I'm going to just, put a few points. What do all of these points have in common? The input is what? The input is 0. We don't know the output, but we know the input is 0, no matter where it crosses. Of course, for this function, we know it crosses only once, right? But all the points they have in common on y-axis is that their first coordinate or the input is 0. Okay, so if this curve crosses somewhere, that point is going to have the same feature. Do you guys follow me? That point is going to have the same feature, which input is 0 and output is whatever. Okay, this observation gives us the guideline as to how to find that y-intercept. Do you follow me? How to find that y-intercept. Okay, what do we do? All the points on y-axis, their inputs are 0. Therefore, in order to find that particular point for this particular function, we should set the input equals 0. The input, of course, is x. Okay, so this observation gave us the guideline as how to find that point we call y-axis. Okay, so you got it? Okay. So here, so in order to find y-intercept, we set x equals 0. We set x equals 0. X is, of course, is the input, right? So when we set x equals 0, okay, we have this function. We set the input equals 0. We set the input equals 0. When the input is 0, okay, come on, you guys, please write it down. So the answer is -3. And these input output together, right? Input output together, comma, output together, what do we get? We get a point, right? Input, comma, output, we get a point. So when input is 0, the output is what? -3. Does everybody follow me? So 0, -3 will be the point where the curve crosses y-axis. Okay, so I'm going to mark that point. Okay, I'm put a red dot. Okay, and I'm going to make some adjustment of these pictures. Okay, so even though you're given the picture, right? But I'm just plotting this particular point to show you that this is the point. This is the point where the curve is going to cross the y-axis. And we know that for sure. Do you guys follow me? So next, I want you guys to draw this picture and mark that point. Mark that point, which is a 0, -3. And I want you to mark this on the picture, please. Zero, -3. When input is 0, output is -3, according to this rule of the function. According to this rule of the function, the point is 0, -3. And of course, from the picture, you can identify some point. But the next point, the next place we want to do is we want to get to question number 4 and 5. Question number 4 and 5, number 4 is really serving number 5. Okay, we're going to go back to that question of making perfect square. And we know the function itself is not a perfect square. Okay? So because it is not a perfect square, we were thinking if this is not a perfect square, maybe there's some partial part of it is a perfect square, isn't it? So we're thinking maybe we can make a perfect square out of part of it. Do you follow me? Maybe we can make a perfect square on part of this function. Okay, so I'm going to leave that over there. Okay, so the thinking out loud part. Okay, I want to write it down for you, and I'm asking you to write it down as well. Even though, right? This does not make a perfect square. Oops. Okay, even though this does not make a perfect square. Part of it could make a perfect square. Right? Part of it could make a perfect square. If we can make a part of perfect square, then we're getting closer to the graph, right? Because we know what happens when we have part of it is a perfect square. We have part of perfect square. Do you follow me? We have part of perfect square. The whole thing is not a perfect square, but part of it is a perfect square. Does everybody follow me? And we can do that. And we can always do that with a quadratic function. So let's see how we do it. Okay, we can do it with a simple algebraic manipulation. So what is the principle we're using? The principle we're using is principle number 2. Anything add 0 stay the same. Am I right? Principle number 2 is anything adds 0 stay the same. Do you follow me? And how do we do that? How do we do that? Right? We notice that x squared plus 2x, we almost make a perfect square. Okay, x squared plus 2x, if I add a 1, I would have made a perfect square. But if I add 1, this equal sign will no longer be valid. They will no longer be equal, right? Because look at this. X squared plus 2x minus 3, x squared plus 2x plus 1 minus 3. These two are obviously not the same. How do I make them still the same? How do I make them still the same? Well, I add 1 and I subtract 1. So in effect, I really added a 0. You follow me? I really added a 0 because plus 1 minus 1 makes 0, right? But I get to split this part, and this will make a perfect square. So the equal sign will still be valid because we added a 0, and we can make the partial of the function in perfect square. Do you follow me? Do you hear the idea? Do you hear the idea? Even though we cannot make the whole perfect square, but we're going to make part of it a perfect square. Yes? And that's what we do. And that's how principle number 2 is used, is adding a 0. By adding a 0, we do not change the nature of the function in terms of input output. The same input still produces the same output. No change. So it's still the same rule, but different look. Do you follow me? It's like me, today I wear, sweatshirt. Tomorrow I wear a purple. Okay, another day I'm going to wear a t-shirt, but it's still me. Make sense? Any questions so far? And then I got my perfect square, and that is x plus 1 squared. And -1 and -3 will combine into a -4. This rule and this rule are essentially the same rule for the rule we started with. It's the same rule because we only added the 0. Same rule, different look. Same rule, different look. Do you guys follow me? However, with this new look, we can identify the vertex. We can also identify the line of symmetry. Okay, we can identify the vertex, and we can also identify the line of symmetry. So now I want you guys to do one exercise for me, okay? How do you graph from x squared? Okay, so you're gonna do something here, and eventually you are gonna graph this guy from what we just learned, from what we have learned since last week and today. Can you graph from x squared to x plus 1 squared minus 4 without having to plot points? Could you do that? Yeah? Starting from x squared. Are you doing that? Yes? From x squared. And what will be the next part you graph? We're going to graph x plus 1 squared. Okay, so let me make some adjustment on the -6 to 4. Okay, -6 to 4. Okay, I'm just making some adjustment to the picture. Okay, so how would you do the graph? Do the shifting left or right, up or down? How do you get that picture from x squared? How do you get the picture eventually from x squared to the picture that you see in your notes? Could you guys do that? If you want me to show or see if you got it right, and feel free to send me a picture by pronto or by the upload in chat. So we first do x plus 1 x squared, right? And then we're going to do x plus 1 squared, right? And then we're going to do x plus 1 squared minus 4. So the next step, we're going to do the shifting, isn't it? So what will be the shifting? Oops. X plus 1 squared. Do we know x plus 1 squared? It's shifted left or right? It's shifted left or right? Shifted left, right? So the line of symmetry in x squared, what is the line of symmetry? It's the y-axis here, right? The line of symmetry here. Line of symmetry. I'm using a broken line. What color should I use? Make it visible. Purple. Okay, that's the line of symmetry, which is a y-axis, right? After we shifted, what has it turned into? What has it turned into? What is the equation now? So this is the green. I'm gonna make it a dash. So this is the line. This is a new line of symmetry, right? And what is the line equation? Remember, we have those quizzes on the question on the quiz. What is the equation of this green? What is the equation of the purple? Can you write down those equations? Yeah. Is everybody with me? Any questions? So the purple's equation, which is line of symmetry for x squared, is x equals 0. So now it's a green. So what is a line of symmetry for the green? We shift it to the left, right? We shift it to the left. What is the line of symmetry? What is the line of symmetry? What is the line of symmetry? Did you write it down? X equals to -1, right? Did you guys see that? I'm sorry, the -1 is not terribly visible, so I'm going to make a change. X equals to -1. So I'm going to make it a little bit higher. Okay, I'm going to make it higher. 6. Okay, do you see that x equals -1? That's a line of symmetry for the green. Okay, and the lowest point, let's identify the lowest point. You can see the shifting of the lowest point, right? So the lowest point on x squared, where is it? It's a 0, 0, right? You follow me? The lowest point here is 0, 0. And we shift it to the left. What will be the lowest point now? What is the lowest point now? The green. What is the lowest point now? Come on, I want a green heart. Can I make a green heart? Can I make a green heart? Doesn't let me make a green. No, it doesn't. It doesn't allow me to make it a green heart. The heart has to be red. Sorry. So what is the point? What is this point? It's a -1, 0, right? Does everybody follow me? So now we're at x plus 1 squared. To complete this transition, we have to do a -4 after the square. So how do we do -4? We're going to shift up or down. Everybody, please tell me. Someone tell me. Marilyn, could you tell me if the green curve should be shifting up or down to get x plus 1 squared -4? Up or down? up or down? Marcelo?
Shift down.
That's right, shift down by 4 units, right? So let's shift down by 4 units. Does everybody get that? Does everybody follow me? How do I know shift up and down? Remember how we shifted? Remember how we shifted? So let's do a little recap. The black, hold on. This black curve, you guys did the homework, right? This black curve is x squared, right? And this green, what is the green? The green is the consequence of shifting up, right? And what is it? It's x squared plus 1, right? So after the square plus the number you shift up, and after the square you subtract the number you shifted down. You guys follow me? Yes, that's your quiz, right? That's your quiz. So the red is x squared minus 1, yeah? Does everybody follow me?
Yes.
Okay, good. Very good. So now, with the review behind us, we do x squared, right? X plus 1 squared. What is x? How do we know x plus 1 squared shift to the left? Because the black here is x squared, the green is x plus 1 squared, yeah? And the red is x minus 1 squared, right? Remember we marked all of these on the quiz? Did you guys follow me? You did the quiz, didn't you? If you have trouble with this, you should go back to the lectures we did last week and to listen to those lectures, okay? To listen to those lectures, to watch those lectures again, and you will get it. I know you will get it. Okay, you just need more, you know, you need to repeat. We need a repetition. All right, so the next picture we're going to generate. Okay, we're going to take this picture and we're going to shift it. We're going to shift down. We're going to shift down by 4 units. Okay, so the final one, I'm going to use red. Now, I want you guys to, from this process, I want you guys to identify this lowest point. What is this lowest point? What is that lowest point? What is that lowest point? We have identified the line of symmetry, right? Everybody? We identify this point, that's 0, 0, and this point is -1, 0, right? Because we shifted left to by 1 unit to the left, and then we shifted down. So from here to there, this red dot, what should be the coordinate of this red dot?
-1, -4.
Perfect. Okay, -1, comma, -4. Okay. I want you guys to think about it. Do you agree with me? If you have any questions, please don't hesitate to ask. So now we're marking the lowest point. Okay, so I'm gonna mark the lowest point and I want you to do the same. Could you do the same? Mark that lowest point. Okay, I'm using color tone, but you don't have to, but it's just right. So I'm just going to clean this up, and that's a -1, -4. Okay, do you guys see that -1, -4 marked clearly in front of you? Okay, I think I can make it better. -1, -4. The red is okay. And I'm going to move it to the other side. -1, -4. Maybe -1 here. What is that? Oh, it's a little covered. Right, so let me do one more time, one more attempt, right? -1.5. Let's see if this will help. But still doesn't look perfect. Okay. So did you mark yours? Did you mark yours? This whole -1, -4. Do you guys follow me? So do you see that? Now compare this -1, -4 with the form with the perfect square. Look at that perfect square. So from the perfect square, okay, from the completed perfect square and the vertex we identified, and the vertex we identify, which is a -1, -4, can we learn something from this experience? Everybody. Have we learned something here? You see, when the input is -1, the output is -4. When input is plug in the perfect square, that perfect square turned into 0. It becomes 0 - 4. Do you guys follow me? Notice f of -1, when we plug in this form, and that's input a -1, and that's going to be 0 squared -4. And in the end, you get a -4. Do you guys follow me? These give us some clue as how to identify vertex after the perfect square is done. Do you follow me? And next, let's look at the line of symmetry. Let's look at the line of symmetry. What is the equation of the line of symmetry? It's x equals to -4. X equals to an input and equal -4. Right? Don't you think they are correlated somehow? Are they correlated? Do they have something to do with each other? Of course, right? We shifted to the left by 1 unit and then we shifted down. So in this process, we have identified the vertex and we can also identify the line of symmetry. So from this form, we can also identify a line of symmetry, and which is x equals to -1. So once you have that perfect square made, once we create that perfect square, and we have another constant. And not only we can identify vertex, we can also identify the line of symmetry. So these are the questions we have on number 4, number 5, and number 8 and number 9. 8 and 9. So number 4 give us the answers to question for number 5, 6, 7, 8, 9. Do you follow me? We haven't covered all of them yet. Does everybody follow me? So once we done that perfect square, okay, we understand that, you know, transition, transformation, moving left, moving right, moving up, moving down. We will be able to identify the vertex, we'll identify the line of symmetry, and we can also identify the range. Because we finally found the lowest point. Didn't we find the lowest point? When input is -1, the output is -4. -4 is an output, and the range is about output, right? And -4 is the smallest output there is. All the other outputs will be larger on this curve. Do you follow me? So from here, from number 4, we can also identify excuse me, range. What is the range? The range is -4 or higher. Okay, so I'm going to give you the interval form, which some of you might know this before. To positive infinity. But my preferred form is all of these. Okay, so this guy is larger than or equals to -4. Which you may not be very familiar with. But the meaning is the same. It just tells the output is going to be always greater than or equals to 4, no matter what the input. The input is all real numbers, right? So the interpretation what does this mean? It means that this rule of the function, okay, in whichever form you have, okay, this function, that's the output, is larger than or equal to -4 for any real number x. That's the interpretation. Or x as input, right? And our function is such, you can use any form, the output, okay? The output f of x is always going to be at least -4. That's the meaning. That's the meaning. Well, do you need to show this much work? You don't need to. Okay, you don't need to. Okay, after this section, I'm going to give you a summary. Okay, so after we finish number 9, I'm going to give you a summary how to show work. Okay, so we're going to have a recap. Oh, I think we need to take a break. We need to take you probably are tired. Okay, and we done the range and number 7, right? How about you guys take a break? Let's take a break, okay? I don't want to overwork you, and I want you guys to stay focused. And I will come back, we're gonna summarize and recap. How about that? Shall we? I can go on for 10 hours, but I have to be aware of my audience. Okay, I don't want to overwork you. Okay, I can go on for 10 hours straight, no problem. Okay, so let's take a break. Back at 12, before we know it, 12:02 p.m. How about that? Okay, I'll see you guys later.
Yeah, I did.
Was that a nice break? Well, it's not too long. Maybe you will say it's not long enough, but we have to go on with the lecture, okay? So what we have said and done, you may have your questions ready. If you don't have any questions, I'm going to just go back to cover the entire 9 questions, the first 9 questions, okay? So let's do a recap. The first of the 9 questions was a domain, right? And the domain is all real numbers, right? And the range is answered much later. Okay, so the domain is all real numbers. You can use the interval, you can also use the word. Okay, all real numbers. Meaning that any number can be the input. Second question, concave up, concave down, concave up because A is greater than 0. Okay, you don't have to tell even A what value A is. You can just say A is positive, therefore it's concave up. Now, third question, y-intercept. How do we find y-intercept? We set x equals 0 and input is 0, output -3. So input comma output, we make that point of intersection, which we call y-intercept, because that's where the curve crosses the y-axis. Number 4, we did a completing a square. Okay, we did a completing a square, so we know that this is not a perfect square. Okay, and can we make a partial perfect square? That's what we did. Okay, so we identified the vertex after we make the perfect square. So how did we make the perfect square? When we make the perfect square, we not only need to know what number to add, we also have to subtract the same number in order to keep that balance. Okay, so if we only add 1 without subtracting 1, and this equal sign will no longer be valid. So in order to validate this equal sign, so we have to consider to make a perfect square and also keep the balance of the identity. Okay, they need to be the same. We cannot change the rule. In other words, we cannot change the rule. You add 1, you have to subtract 1. Okay, so we made the perfect square. After the perfect square is made, we can identify the vertex, right? We identify the vertex by shifting, which we did. Okay, we did the shifting and identify the vertex. And you can also identify the vertex by, okay, this is going to be -1, positive, -1, -4. -1, this is +1, and this need to be -1. And the bottom line is that if you notice you plug in, you need to make that perfect square part equal 0 to identify that input, output, which is the lowest point. Do you guys follow me? There's a lot of details in here. If you miss 1, you might be in some kind of trouble down the road. Okay? Do you follow me? Everybody? Okay. So now we can also identify the line of symmetry. The line of symmetry can be identified in two ways, either by identify the vertex, right? Once you identify the vertex, the line of symmetry is just x equals to that number. Do you guys see that? And we also can identify the range. The range is about the output because we have the lowest point, so we will have the smallest output, the smallest y value. So that comes to question number 7. Number 7, maximum y value or minimum y value. And here we don't have a maximum value because the maximum value can be as large as possible. But we do have a minimum value. And the y value here, we min the output. So the minimum y value, okay, i.e. the minimum output is -4. Okay. Number 8 and number 9 is drawing and identify the line of symmetry. Of course, we know the line of symmetry, right? You can draw the line of symmetry, but you also have to write the mathematical form of that line of symmetry, which is, of course, we have already done this multiple times. So draw the line of symmetry. So now, would you guys please draw the line of symmetry in your notebook, please? So that's the first 9 questions. Okay. Now, do you have to write this much for these 9 questions? I'm going to give you a version of this, how much work you need to show to the teachers right now. Okay, the first 9 questions. Okay, to expedite this process, I'm just going to show you. Okay, so summary. Summary of answering the first 9 questions. Are you guys ready? And then we're gonna go on from there. Okay. You're gonna see I'm gonna trim some fats. Okay. As a student, when you look at this question, you answer. Okay. Domain and range, you don't have to give me both. One is enough. Okay. You can give me either this one or give me all that, all real numbers. And for this one, you can just write a larger than 0 is concave up. Okay. For y-intercept, we can keep the whole thing. Do you need the picture? No, the picture is optional. The picture is really optional. But you may like to have it in a stretch. Okay, so this picture is optional. But you know how to do it. You know how to put the points in place. To make the perfect square, you can go straight. You can go straight to find the perfect square. Okay, and these are the steps of showing perfect square. And that's number 4. Number 5, identifying the vertex. Okay, that's enough. Identify the vertex. Number 6. Okay, number 6. The range. Which version of range do you want? Right? I'm going to give you some options. I'm going to give you options. This answer is okay. This answer is okay as well. Okay. Options of correct answers. options or correct answers. This is one option. And this is another option. And this is another option. Okay. And all three options are fine. Number 7. Draw the line of the minimum y value. Minimum y value. Y is the output. Minimum y value is -4. Follow me? Minimum y value is -4. Number 8, draw the line of symmetry. Draw the line of symmetry. Number 9, give the equation of the line of symmetry. So this is 1, 2, 3, 4, 5, 6, 7, 8, 9. Is that clear, everybody? Let me give you, I'm going to give you a little time. Okay, so let me remove that picture. So do you guys see everything? 1, 2, 3, 4, 5, 6, 7, 8, 9. Are we good so far? Are we good?
Yeah.
Okay, so you got it. 1, 2, 3, 4, 5, 6, 7, 8, 9. Now we're going to move to the next section. The next section is starting from 10. Okay. Number 10. Okay. Number 10. I had my y-intercept done, right? I had my y-intercept. So next I'm going to identify the x-intercept. Okay. So what are x-intercept? Of course you can identify the points from the picture, but that's not the point. What if the curve doesn't sit on the perfect numbers, right? Can you still identify the x-intercept? That's the question, right? So for this question is easy. So I still want to teach you the systematic way to find x-intercept. Do you follow me? We need to learn that systematic way to find the x-intercept, because not all x-intercept will sit on those perfect numbers. Okay, sometimes they sit numbers in between perfect numbers. How do we identify those? Do we have a systematic way to do it? Of course we do. We do. Okay, so on number 10, we're going to find x-intercepts. X-intercept. And we may have more than one. You see, when we talk about y-intercept, we only have a singular. For x-intercept, however, we have a plural. We have a possible plural. Why is that? Does that mean we can only have one y-intercept and we may have more than one x-intercept? Why is that? I want you guys to think about it. Why you think about it, okay, is how do we identify these points, right? How do we identify the points that intersect with x-axis? Okay, so I'm going to draw this curve here. So how do we identify these 2 points? Now, these 2 points is not as easy to identify as the pictures I show in the notes, right? In order to find x-intercept, we need to understand the meaning of the intercept. What is the meaning of these intercepts? We have a point here. we have, let me use this. We have a point here and we have a point there. We want to identify these 2 points, pretending they're not sitting on those perfect numbers. What do these 2 points have in common? They're sitting on the x-axis, right? What is the special feature of points that's sitting on the x-axis? Their y-coordinate is 0. In other words, their output is 0. You follow me? So we don't know the x coordinates, we don't know the input, but we know their outputs must be 0. You follow me? So from the function's perspective, when we try to find x-intercept, what do we mean? Is we mean that we have this function, we have this rule, and we want the output to be 0. And we want to identify all the possible input such that the output is 0. Do you follow me? So still, you can see it's all about input output, isn't it? And this perspective basically tells us how to find the x-intercept, which is to set the output equals to 0. Do you follow me? So in order to find the x-intercept, we set y equals 0. We set the output equal to 0. This is the reason why. Okay, are you guys ready? All right, so in order to find the x-intercept, we're going to set the output 0. What does it mean set output equals 0? What is the output? The output is f of x. We're setting f of x equals 0. What is f of x? What is our f of x? Our f of x are in all these different forms. All of these are f of x. Okay, this is f of x. This is f of x. And this is f of x. So this is f of x. Okay, this is f of x that was originally given, and this is a transferred form. We don't use it. We're not going to use it. We can choose not to use it. And this is the final form with the perfect square in it. So you can use any one of those forms, but each one give you the output. This will give you output. This will also give output. And we set that output equal to 0. That's what we meant by setting the output equal 0. Does everybody understand? You follow me? It's all about input output, guys. Now, the question is, which form do you want to use? Oh, sorry, there's not 40, it's 4. Okay. The question is which form you want to use. The question which form you want to use. You can use this form, of course. But today I'm going to use this form. Okay, I'm going to use this form. So, because I'm using this form, okay, so we're going to solve for x from that form. Do you guys follow me? Okay, so what do we get? This form actually looked like something we have learned before, didn't we? If we add 4 on both sides, we add 4 on both sides, we get x plus 1 squared equals to 4. Did we see these forms sometime before? How about alpha 11? I believe it's alpha 11. Did we see alpha 11? Did we see this in alpha 11? Remember that 3 types of equations we solved? Yeah? Did we solve those 3 types of equations? Absolute value, square root, and the perfect square equals something. Remember that those equations?
Yeah.
Yeah, so now that gets to be used. Okay, so let's solve this equation. So if this is true, what do we do next? We'll take a square root on both sides. That must be true as well. And what is on this left-hand side? It's absolute value of, oops, what did I get? Here. X plus 1 must be just same as 2 because square root of 4 is 2. Then what? That means X plus 1 is equals to plus 2 or minus 2, right? Plus 2 minus 2. And then what? We basically have 2 cases, right? That is X plus 1 equals to negative 2, or X plus 1 equals to positive 2. In the end, what do we get? We get X equals to negative 3, or X equals to 1. So you can see by setting the output equals 0, we get 2 inputs. So when we put these information together, what do we get? When input is negative 3, the output is 0, right? Or when input is positive 1, the output is 0. Do you guys follow me? Yeah? And these 2 points are sitting on the x-axis. Therefore, we call them x-intercepts, and we have 2 of them. Have you guys figured out why we have only one y-intercept, and we may have more than one x-intercept? Have you figured that out? Okay, you can check your answer. How do you check your answer? This point says, okay, you can use any form to check, really. You can use any form, okay? I want you guys to check if your answer is right. How do you check your answer? You plug in negative 3, and you're gonna plug in positive 1. We should be getting zeros if we got them right. So could you guys check for me? Could you guys check it for us? Can you do that plugging in to verify that when input is negative 3, the output is 0, or when input is 1, the output is 0, right? Plugging in. Plugging in, plugging in, plugging in, plugging in. Do we get zeros? We should be getting zeros. Otherwise, we have made a mistake somewhere. So this is going to be 0, right? Because 9 minus 6 minus 3, that's 0. And the next one, of course, is 0 as well. So what have we found? We found the two x-intercept. So next, I want you guys to mark them in that picture. Mark them in that picture. So where's our picture? Okay, I have pictured, of course we have the picture right there, right? So now we can mark these 2 points. Okay, we got -3, 0. I'm gonna make it a red dot. Another picture, another point, 1, 0. Oh, what did I do? It doesn't mark. Okay, point. Could you mark these points for me, please? Could you guys mark this in your picture on the graph? -3, 0. Mark each pictures there. -3, 0 is 1 point. One more point. 1, 0. Right? Did you mark them? 1, 0. Okay, properly marked. Properly marked. Okay. I just make some minor adjustment. Oh, this make it worse. I'll shift it. It's better, right? It's better. Okay. Y-intercept, x-intercepts. We have 2 x-intercepts. You may be thinking, do we always have x-intercepts? That's a good question, right? Do we always have y-intercept? That's another very good question. We should be thinking about these questions. We should be thinking about these questions, right? Now, we did number 10. I scroll back. I want you to see how we have done it. We're setting the output equals 0. And we solve the resulting equations, which we end up with something we were familiar with. We are familiar with it, right? Alpha 11 or something like that. And we solve it and we compose the line, we'll compose the points that we call x-intercepts. And we can check our answers. We can check our answers. And we can also put the points on the chart, on the graph. And we mark those points on the graph. You follow me? If I ever ask you guys to do these by hand, and I expect you to mark the points the way I did here. Okay? So far, so good? So far, so good? Now,
Yeah.
Any questions? So we done?
No, I'm good.
I'm sorry?
No questions for me.
Okay, how about everybody else? How about everybody else? No questions? Everything is clear? All right, so next, we're gonna attack question from 11 to 18. You can see these questions somewhat similar. Some questions are similar, but some questions are different, right? So we're gonna explain to you what it means, okay? And this is also the place that a lot of our students get confused, right? So we just did number 10. We just did the number 10, so let's work on number 11. Ready? Come on. Doesn't go down, but anyway. Number 11. Number 11 says, evaluate f of 0. What does that mean? Evaluate f of 0. And number 12 says, solve the equation f of x equals 0 for x. These kind of questions often get our students very, very confused. Does it confuse you? Does it confuse you? One is evaluate f of 0, and the other one is solve the equation for f of x equals 0. We got 0 here, we have 0 here. What's the difference? Could anybody tell me what's the difference?
The 0 is in the f. I mean, is in the x.
Okay, tell me, what is, in terms of input output, what does this notation tell us? The 0 is for input or for output? And there's another 0. Is this 0 for input or for output?
So the first one is for input and the second one is for output.
That's a perfect answer. That's the perfect answer. Very good job. Very good job. That's the difference. That's the difference. Excellent. Okay. So in the first one, it really meant that I'm going to give you 0 as input. That's how we get f of 0. And the output is going to be f of 0. Okay, very good answer. I'm so pleased to hear that. Okay, but I still want to put it up there to make sure everybody, get this. The second one, okay, is still in this relationship, right? The function. But this time, because the output is f of x, and we are told f of x is 0. So basically, we are told the output is 0. We're looking for input. So in this first case, given input 0, want output. In the second one, in number 12, is saying if the output is 0, find me all the inputs. Does that make sense? That's the meaning. That's a difference in meaning. Okay, I'm so glad you got that. Does everybody get that? All right, so when we evaluate f of 0, once you understand that difference, it's really just a matter of doing it. Okay, f of 0. Wait a minute, have we done f of 0 before? Have we done this before? Look at your notes from between number 1 through number 9. Did we do f of 0 before? What is f of 0? When we try to find y-intercept, we set x equals 0. And we did f of 0 there. Yeah? You guys follow me? So we've done it, right? We've done it. So f of 0 was done before. So this is really just another way to say what? Find the y-intercept, isn't it? So question 11 and y-intercept are the same question. Question 11 and question 3, they're the same question. Are you guys with me? They're just asked in different ways. Okay? Now, number 10. I'm sorry, number 12. Given the output is 0, and what is the output? What is our output? We have so many forms of output, didn't we? We have 2 output equals 0, right? Didn't we do that at number 10? So number 10 and number 12 are the same questions. Do you guys follow me? They're just asked differently. Did you get it? So we can copy the entire section of number 10. Okay, right here. The entire section for number 12, number 10 is the same question as number 12, which is to find x-intercept. Okay, so setting the output equals 0, setting the output equals 0, and that's the implication, and that's what we did. Does everybody follow me? You see, math questions, sometimes they're the same question. You just have to understand the meaning. Understand the meaning is most important. Yeah? So setting that equals to 0, right? It's all of that. We've done it. Been there. Okay? And we got the points. We got the points. That's number 12. But number 12 didn't ask us for the x-intercept. They didn't ask for the point. They just want the answer for x. So there you go. You just remove the x-intercept. And you're done. Does everybody follow me? I want you to compare number 12 with number 10, which you took notes of. Isn't that interesting? Isn't that interesting? Does everybody follow me? So we know number 11 is the same as the question number 3, and number 12 is the same as number 10. That's the algebraic aspect. That's the algebraic aspect. I'm going to give you the geometric aspect. Are you ready? What is the graph? What is the aspect from the graph? What is the aspect of graph? Okay. Number 11, given the input, looking for output, what is the geometric interpretation? What is the geometric interpretation? We have this graph, right? We kind of have this graph. And we have the points in place. When we say x equals 0, the input is 0, what is the geometric meaning? The geometric meaning is that we're cutting the curve vertically. Okay. Okay. We're cutting the curve vertically with the green. This line, this green line is x equals 0. Okay. This green line, okay, this green line is x equals 0. That's the y-axis, right? The equation of the green is x equals 0, which is the y-axis. By giving us the input equals 0, we're given this green line that's cutting the curve. And when we cut the curve, there's a crossing, and that crossing is 0, -3. Do you follow me? That's the vertical cut. When input is given, it's a vertical cut. You follow me? That's the geometric meaning. Yeah? Now, what if the output is given? What if the output is given? What if the output is given? When the output is given, it's a horizontal cut. It's a horizontal cut. Okay, so let's cut it. It's a horizontal cut. And the line of cutting, what is the line of cutting? The line, the red line, the equation of the red line is what? Is y equals 0. Oops, I need to use red. Sorry, I need to use red. That's the meaning of differences. One is a vertical cutting and one is horizontal cutting. Do you guys follow me? So there's an algebraic difference and there's a geometric difference. Okay, when the input is 0, when we are given input is 0, it's a vertical cut. And that vertical line that cutting it is input equals 0. Do you follow me? The input is 0, x is the input, so x equals 0. When we cut horizontally, the output is 0. The output is y. Y is 0. Do you guys follow me? Is that pretty clear? Is that pretty clear?
Yeah.
Very good. Anybody else? Anybody has any questions? And please, if you have any questions, please don't hesitate. Don't hesitate to put it in the chat or just speak up. Or private if you don't feel comfortable to ask in front of everybody else. We got it? So that's the difference. Okay, that's the difference. Next, number 13 and 14. Number 13 and 14. Okay, number 13 and 14. If you understand, we just explained to you for number 11 and 12, number 13 and 14 are similar. One is a vertical cut and one is a horizontal cut. Do you follow me? So let's work on that. Let's work on it. So number 13 and 14. Number 13, number 14. 13, 14. Okay. 13. 13 says what? Okay, I'm going to copy and paste the third number 11. 11 says evaluate f of 0, right? And on 13, we say evaluate f of 1. So what has changed? The nature of the question didn't change. Only the number has changed, right? What was in number 12? Solve the equation f of x equals to 0. And now we have solved the equation for f of x equals to 1. What has changed? The nature of the question hasn't changed. Only the number has changed. Does everybody follow me? Does everybody follow me?
Yes.
Okay. So let's look at the geometric meaning. So this time we change the direction, right? So we're gonna have a cuts. One is a vertical cut and one is a horizontal cut. Can you tell me which one is a vertical cut? Number 13 a vertical cut or number 14 is vertical cut? Number 13 is going to be vertical cut or horizontal cut? What is a cut? What is a cut? There will be a cut about one, right? There's one horizontal, there's one vertical. Which one is for which? Which one is for which? The green is x equals to 1. The red is y equals to 1. So can you tell me, okay, so I'm sorry, this one I need to change the color. Sorry about that. I'm going to change the color to green. Does it allow me to change it? It doesn't allow me to change different colors. I'm sorry. Okay, so you just have to, the green line and the red line. Okay, which line, which cut is for 13 and which cut is for 14? Can you tell me? If you think you have been following me, you must be tired. I know you might be tired. F of 1 is the input is 1, right? The input is 1. So you're going to look for what is for input. Input is 1. So the vertical cut is for 13. The horizontal cut is for 14. Do you follow me? Yes? So that's a geometric meaning. That's a geometric meaning. So let's see, how do we find f of 1 when input is given? Okay, we have the function, which is, x squared plus 2x minus 3. We just have to replace x by 1, plug in, and we get 0. We get the point. And the point is 1, 0. So when input is 1, the output is 0. So how about for number 14? I'm waiting. Did you guys write it down on your notebook? Mark the green and the red, the lines. Okay, because I'm going to make them disappear. Okay. I'll bring them back up. How about this one? Oops. How about the number 14? What did it do? What did we do for number 12? We set the output equals 0 for number 12 because the output was set to be 0. And this time the output is set to be what? To be 1. So now the output is set to be 1. That's the horizontal cut. That's the horizontal cut. Okay. So we are actually solving for x, and you can use any one. I'm going to use this one. From that one, because we know what to do. It doesn't mean you cannot do the other one, okay? We can also do the other one, but just to maintain consistency with what we did in Alpha 11. And this time I'm going to add 4 on both sides. So I'm going to have x plus 1 squared equals to 5. Okay, this time the number is not so nice and neat, but that's okay. It's just a number, right? So we're going to take square root on both sides, just like what we did before. And the root 5 is root 5. Just leave it at root 5. And over here, once more, absolute value of x plus 1 equals to root 5. And solving that absolute value equation, what do we get? We get x plus 1, just like Alpha 11. Okay, we get positive or negative root 5. Right, we're pretty familiar with these steps. And then finally, we're going to isolate x by subtracting 1. So in the end, we get x equals to, okay, we get x equals to -1 minus or plus square root of 5. We were just talking about the cutting, right? We're just talking about the cutting. So now we got a solution. How are these solutions related to the crossings of the cutting? So we have 2 points. One is x1. We call it x1, sorry. That's equals to -1 minus root 5. And we have another point, which we call x2 sub 2, which is going to be -1 plus root 5. Where do you think they are? Where do you think they are? Can we find a spot for them in this picture? Yes, there are 2 spots, 2 points, because you see the red horizontal line cuts the curve. And the crossing, what is the crossing? The crossing is, one is, okay, the red horizontal line crosses the parabola at 2 points. One is this one, comma 1. And there's another point, plus root 5, comma 1. Okay, so these are the 2 points of the crossing. They don't look nice and neat, but if you just input in this, you know, I'm going to mark them. Okay, I'll make it red point. Just dot or cross. Okay, let me try cross. And there's another point. Which is, we have 2 crosses. Can we see the 2 crosses? Barely. It's hard to see. You guys see the crosses right here? There's a cross here and there's a cross there. Okay, do you guys see that? These are the 2 crosses. Okay, we're running out of time. Can you mark these 2 points? Okay, to wrap up today's lecture, I'm going to mark these 2 points for you. This cross, okay, I'm going to use a stamp. Okay, this heart and this point. Okay, to conclude today's class, we're going to mark these 2 points and we're going to continue on Monday. So this point is going to be, I'm going to use black color. Okay, so that point is -1 minus √5. That's the input. And the output is 1. And that point is -1 plus √5 for input, and the output is 1 as well. So that's the consequence of cutting. And of course, the green crosses the curve at 1, 0. We already know that. Are we good? Are we good? Vertical cut, horizontal cut. Okay. Expect a quiz. Expect a quiz. Okay, but you guys have done a very good job participating. It seems you understand, which I'm really glad. But if you have any questions, please don't hesitate to ask. Okay. So today after class, I will ask you guys to do everything we have done in class all over again. Okay, especially with completing a square. Those are not trivial. Okay, those are not trivial. Make sure you really go through these, and your quiz will be based on the lecture. Okay, your quiz will be based on the lecture. Any other questions? Do I see you Monday?
Yeah, that's good.
All right. If you have any questions, please don't hesitate, and I will make up a quiz for you that cover today's class. Okay. Stop recording. I'll see you guys.